Welcome to the Quick Start video guide for configuring OKAPI as a bridge router. The objective of this demonstration is to showcase versatility of OKAPI routing platform to behave as a router as well as a bridge, that is, routing packets for known protocols and simply forwarding the rest as a bridge would. To set up the B router, we will use the industry standard CLI. First, we identify the need for bridging. Thereafter, we will configure bridging through the bridge command and also enable STP or spanning tree protocol for the bridge. In the next step, we will set up the interfaces for bridging, that is, associate the interfaces to our bridge through the bridge group command. Additionally, to allow routing of packets, we will also configure dynamic routing over the same router. Finally, we would verify the coexistence of bridging and routing. The current slide delineates the diagram of our hypothetical network across which our OKAPI routing platform will be configured as a B router. The device under test is router A, or the one with the oblique red stripes. Router A's serial interface is connected to router B's serial interface on the 10.5.5.0/24 network. The Ethernet interfaces are connected to two separate LAN segments, that is, LAN 1 and 2. Here, LAN 1 consists of machine 1 with the IP 192.168.1.10/16 and LAN 2 contains machine 2 with the address 192.168.1.20/16. In other words, we have two physically separate segments which belong to the same logical subnet. Clearly, the effective requirement would be to establish a logical bridge between the two LAN segments so that one can exchange packets between them and also forward packets for the point-to-point link between router A and B, that is, dynamic routing to be available for the serial interface. The same is being depicted by the flipped network representation with the bridge between the two LANs. The network configuration that was depicted pictorially in the previous screen is being implemented in the virtual environment of VMware. The test suite designated as PPP will now be powered on. This will bring up router A and B and the two network machines in quick succession. Starting from network machine 1, from the video, one can observe that the IP and default route has been set. One can also see that machine 1 from LAN 1 cannot ping machine 2 on LAN 2. This is because even though both the machines are in a single logical subnet, they belong to two different physical networks. This is where bridging comes into picture, because a bridge is a device that separates two or more network segments within one logical subnet. Next, we proceed to router A. Let's see how routing and bridging can happen simultaneously on our OKAPI router. We start with configuring bridging on router A to demonstrate the coexistence of routing and bridging on it. First, we create a bridge with ID 1. To check the various parameters available with the bridge command, press the question mark key. The configuration options which are now available are forward delay, hello time, max age, priority and spanning. Out of these, we will now use spanning to enable the spanning tree protocol. Next, we make Fast Ethernet 0 and Fast Ethernet 1 the members of this newly formed bridge. For this purpose, we would now execute the bridge group command at the configuration mode of each interface. After that, we assign an IP address 192.168.1.1/16 to the bridge interface to make it a part of the same logical subnet. Configurations made so far can be viewed by executing the show running configuration command. The two Ethernet interfaces are now bridged on router and will act as a single logical interface which will be referenced as bridge VI1. Moving on to machine 1 on LAN 1. Before we configured bridging, we had demonstrated that machine 1 could not ping machine 2 despite being on the same logical subnet. However, after bridging, both the LAN segments are bridged through our router. Hence, both the machines can ping each other. For example, machine 1 can ping machine 2. The same phenomenon will now be observed on machine 2. Coming back to router A, we now disable bridging on fast Ethernet 0 through the no bridge group command. One will observe that now machine 1 cannot ping machine 2 because the bridge is broken, which implies that the two LAN segments are disconnected. However, if we again enable bridging on fast Ethernet 0, it brings back the bridge. This is verified by pinging machine 2 from machine 1 and vice versa. Till now, we have seen router A working as a bridge. In this segment of the video, we will now introduce dynamic routing. So configuring dynamic routing through RIP. RIP is enabled on the bridge interface through the network command. Prior to enabling RIP on async 0, we need to establish a serial link with the neighbor router, router B, and also assign IP address to it. At this juncture, we also verify routes using the show IP route command. We now validate the serial interface's connectivity with the pair router through ping and finally we enter the router mode to enable RIP for the serial interface as well. To see the RIP discovered routes, let's use show IP route command again. One can see the RIP discovered route to network 192.16.0.0/16 via serial interface. Proceeding on to machine 2 on LAN 2, we can ping machine 1 which verifies bridging. Also, machine 2 can now reach router B, that is 192.16.1.1, which verifies dynamic routing using RIP at our router. Similarly, proceeding on to machine 1 present on LAN 1, one would observe the same phenomenon here as well, that is, router A behaves as a bridge as well as a router. And on this interesting note, we also conclude our presentation.